Okay, hello everyone. Hope you can hear me. So next class is our midterm exam. Although the class starts at 6:30, I'm going to make myself available like about 10-15 minutes sooner. So if you show up sooner than that in class, I'll give you the password so you have a few extra minutes to do your exam. Please remember that your camera must be on all the time so I can monitor you taking your exam. It is out of my hand. It is, wanted by the department. Okay, I had some requests for going through some of the material, so I'm going to go ahead and start with that and uh, make myself, let's see. The one of the questions that was asked from me was, what if you have something like minus 3x to the second minus, let's make this one variable, just x, plus 24 and greater than or equal to 0. And we want to solve, solve. In other words, what do we mean by solve for that? Because it's not going to be a point. It's going to be a range of x's that would make this statement true. In other words, what's the range of the, let me write that. What is better than that? Let me just say, what is the domain of this inequality? So for example, when x is 0, on the left-hand side, I get 24. Is 24 greater than or equal to 0? Yes. What if x is 0.1, 0.2, 0.3? I mean, we can't sit here all night and just test numbers. So we might as well find the range of the, or in this case, I should say, instead of the word range, I find the domain of this function. So from what number to what number does this inequality hold? Okay. So this one, in order for me to figure out the critical points, I have to set that equal to 0. So first, set equal 0 for critical points. So what are the critical points? If I say minus 3x to the second minus x plus 24 equals 0, in other words, well, first of all, let me also tell you that the graph of this function f of x is going to be something like this. All right. And the question is asking that for what range, for what range, or I shouldn't say yes, for what is the domain? What are the total numbers that would make this inequality true? And just looking at the graph, you can see that somewhere in between two different values, the graph is going to be above the x-axis. So because this is a greater than or equal to 0. So let me go to the next page. So that was a rough graph, by the way. So don't let that bother you. That, oh, how did he notice just to graph it like that? Well, all I know is a cubic graph. And since there's a negative in front, there's a reflection about the x-axis. That's all I knew. So to get critical point, step 1, get or find critical points. And you can, if any, of course, and in this case for sure. So I have minus 3x to the second minus x plus 24 equals 0. So here I need to, I have two choices. I can do quadratic formula, so I can do quadratic formula or try to factor. factor it. So in this case, I'm going to go ahead and try to factor it. I'm going to use using AC method. If you're not familiar with it, or if you're rusty, I did put video on Canvas for learning how to use AC method. So first of all, I'm going to go ahead and multiply both sides of this. Not both sides. I'm going to multiply this 3 by this 24. So that gives me x to the second, and let me minus x, and then minus 72 equals 0. This is just, this is, I'm not saying that this is equal to that. I'm just using AC method. Please make that distinction. My first equation does not equal to the second equation. We're just using the trick to, to factor this. So now, if I factor what's in front of me, then I have x minus 9 and x plus 8. So negative 9 times 8 is negative 72, and negative 9 plus 8 is negative 1. Now I'm going to tell myself that I did multiply by negative 3, so I'm going to divide by negative 3. So this becomes x plus 3. Okay, and this, since this is not divisible, put the negative 3 as a coefficient of x. So x plus 8 equals 0. Now, I'm going to test myself. Did I do this factoring right? Well, let's see. X times 3x is 3x squared. I'm good. X times 8 is 8x. And then I have minus 9x, and 8x gives you negative x. That's good. And positive 3 times positive 8 is positive 24. So yes, my factoring was correct. So let's go to the next page. And so for the critical points, now I have x plus 3 and minus 3x plus 8 equals 0. Well, now using zero product property, x plus 3 equals 0, and minus 3x plus 8 equals 0. So this gives me x equals minus 3. This gives me, let's see, 8 equals 3x. So x equals 8 third. So number line, if I put the 8 third in here, and I put negative 3 in here, I'm going to test numbers in between these. Well, to the left of negative 4, if I plug in, let's say, to the left of negative 3, let's say negative 4, negative 5, negative 10. And as you can see, if I put, like, say, for example, negative 10, I get a negative value in front. So this makes this interval false. That wouldn't give me any value. Any number you pick to the left of negative 3 will give me a false statement in relation with our original problem. How about between negative 3 and 8 third? Let's say 0 is convenient number. Sure, I'm left with 24. Is 24 greater than or equal to 0? You bet. So true. Okay. And to the right of 8 third, let's say positive 10. Again, I get a false statement. Whatever value I get on the left is not going to be greater than or equal to 0, because you are getting a negative. So the answer to this, to this inequality is from negative 3 over 8 third, and negative 3 and 8 third are included. How did I know that without testing any number? Because our original question was minus 3x to the second minus x plus 24 greater than or equal to 0. When you have this equal, then these boundaries are included. But you're more than welcome to test negative 3 and 8 there as as you want.
Could you go over the strategy for getting the factors again?
AC method, sure. I'll go over that, and also, so one more time, I would like to, and I don't want to be let me go through that again, and I'm going to just ask you, maybe somebody, one of you, to go to Canvas and see if um, if the video is there, because I don't want to be a liar. I'm 99% sure I put it there, but it's probably fourth video from right under the syllabus. I have like 3-4 examples. All right, so let's do this from the beginning. Let's say that I had minus 3x to the second minus x plus 24 equals 0. So let's say that this is my A, this -1 here is my B, this 24 is my C. That's logical. And this method is named AC method. Okay. And now, so what I'm going to do, I'm going to multiply A and C. So x to the second, so A, I'm not going to write, don't write original A down. So now my coefficient is 1. So x squared, okay. Then I have minus x, -3 times 24 is -72. Now, remember, this is not the same as this. It's just a trick we are using to, to factor it. So the trick is, first, we multiply by -3, and then after we factor this, then we divide by -3, so we undo that process. So now I'm going to factor this to x minus 9 and x plus 8. Do you agree with this? Do you agree that these two are equal?
Yes.
Okay, so now in the beginning I multiplied by -3. Now I'm going to divide these numbers by -3. And the rule for that trick is that this one is divisible, so you get x plus 3, no decimal. This one is not. 8, -3 doesn't divide 8. So the rule is, and some teachers say, bottoms up, like when you drink your, I don't know, some high school teachers say bottoms up. That means that you put this bottom up here for the coefficient of x, so this is now -3x plus 8. And now if let's just convince ourselves, x times -3x is -3x squared, x times 8 is 8x, then -9x give me -1x that I had in the beginning, and 3 times 8 gives me 24.
Got it. Thank you so much.
Absolutely, yeah, absolutely. Okay, there is another one that I got an email, which is actually so much easier. This one was only something like b to the second greater than or equal to 4. Okay, and we want to solve. And this one, the thing to remember for this one is that we need 0 on the right hand side. That's the key. So I'm going to write this as b squared minus 4 greater than or equal to 0. So this is going to be b plus 2, b minus 2, difference of 2 squared greater than or equal to 0. So the critical points are going to be b equals -2 and b equals to +2. So -2, +2. So to the left of -3, -2, let's say -3. -3 squared is 9. Okay, is 9 greater than or equal to 4? Okay, Thank you, Michael or Michelle. Like that. We'll check it in a minute. Thank you. Thank you so much. -2. So to the left of -2, let's say -3 gives me a true statement. So it's going to be true in here. Between -2 and 2, natural choice is 0. 0 is equal to 0. Is 0 greater than or equal to 4? No. So false. No answers in there. But how about to the right of 2? Let's say 10. 10 squared is 100. 100 is greater than or equal to 4, so true. And since I have this equal sign in here, then I'm not going to test the -2 and +2. Now, please keep in mind, would you please, if you can remember, I'm not testing these numbers because it will, if you have the equal sign, it will always, you never have to test it if you have the equal sign. So you probably, some of you think that, hey, you know, I can swear that I saw my high school teacher test this -2 and +2. You test those numbers when you have a rational function, when you have something on the top of something. In this case, I have a polynomial, you know, so I don't have to test it. So in like soon, in a couple of the problems, like maybe towards the end of the quarter, you know, that we deal with the rational functions, which is a polynomial on the top of a polynomial, then we test those numbers. Okay, so the answer for this one is going to be from parenthesis, because we don't give bracket to infinity, from -infinity to -2, together with from 2 to infinity. Okay, so and now I have to, let me grab my, because I need to get a code to open Canvas. If I don't have that video in there, I'll be very embarrassed. Give me one.
I looked at WAMAP, not on Canvas. Sorry. It might be on Canvas.
Okay, yeah, it's on. Can you go to Canvas? Is that
Yeah.
easy for you? Go to Canvas, please.
Yep.
And like below the syllabus when it says helpful videos, it should be third or fourth video. Do you see it?
I need to log in, but I'll find out.
Oh, okay. Okay, I can log in from my side too. So go to CTC link. They are, you know, nowadays for me to get to Canvas, I have to get 2 different codes on my phone because the hacking has been really crazy recently. It's been really, really bad. So let's do the first one. 80562. Okay, so now, okay, click on Canvas. Okay, I'm just keep cleaning on this screen, so I need another password that's going to be texted to me on my phone. 72. Okay, so I'm on Canvas and 141. Okay, when you go on helpful supplemental videos, yeah, it's okay. I didn't 1, 2, 3, 4, 5, 6, 7, 8. It's actually the 8th video, and the title is Factoring Trinomials with Coefficient Other than 1.
Okay, yeah, I see it.
Yeah, it's the 8th video. So yeah. Oh, good. So I don't have to. I don't have to now worry about it after class. That's good. Okay. So excuse me. Let me. So let's see another one. Okay, and I guess somebody else put it on the chat. Thank you very much. Appreciate it. There is a question on section 3. The section has that 3.4 and 3.5 combined together, and it's talking about the oh yeah, the direct direct where is directly or direct variation and put that inverse variation. Okay, so what is that direct variation and what's the the inverse variation? The direct variation, that is when you have two factors, one of them goes up, the other one goes up. Like for example, in your car, the more gas or in your stove, the more you turn it up, your gas stove, the heat goes up. Of course, up to a certain degree, we know that. But so one thing going up takes the other one up. Sometimes in life, however, is the things are inverse of each other. So, like for example, if you go into the ocean, okay, the further down you go, the harder it is to hear, the harder it is to swim, and on and on. So there's something that affect each other inversely. Like let's say if you have a fire, the more water you put on it, well, you're going to have less fire. So one goes up, the other one goes down. So they inversely affect each other. If I have a headache, and let's say I take ibuprofen, the more ibuprofen I have, the less headache I'm going to have, theoretically. I know you probably think that, what if your headache is from something else? But so some stuffs are, some stuff vary directly, some stuff very inversely. And so you probably think that, what if you have a mechanism that has more than two factors, like your car? First you drive, the heat goes up, the engine gets hotter, but then your radiator kicks in and it makes it cooler. So you have more than one factor. How do we deal with that? And the same way. So for this section, we're just dealing with really basic ones, just two factors. So let's say that in this one, and finally my cough is getting better, goodness. The intensity of television signal varies, and it's number 15. Let me just actually go ahead and write that in here, that it is 3.5, number 15. The intensity of a television signal varies inversely. So we have TV signal varies inversely as the square of the distance from the transmitter, If the intensity is 16 watts per square, so now the given information is if or when the intensity is 16 watts per square meter I know somebody in this class always goes and comes back. I have to please tell you, if you do that on your exam, I'm going to drop you. You can't go and come back. You cannot use your phone, your midterm. You cannot, you must be on a desktop. You go and that's the end of, you can't just look at the questions and come back. So whoever you are, I'm giving you a fair warning. You can't do that in, for the exam. Per square meter, so let's say if the intensity is 16 watts per square meter at a distance of 0.75 kilometer, what is the intensity? What is the intensity of a signal at a distance of 2.25 question. Oh. Please write this down. I'm going to go to the next page and first tell you, and I put star by it because so. Can you go to the next page? Are we okay? Cool. Let's go to. So, if you have direct variation, then you have y, or one factor equals k times x, k a constant. Okay. If you have, if you have inverse variation, then you have y equals k over x. So x is now in the denominator, which is the same as saying, k times 1 over x. Some students like that better because k remains the same, but inverse of x is 1 over x. So now the word inverse is there. This is the formula we are going to be using. This is the formula we are going to be using. So it said that, let's say.
Can you go back to the inverse variation?
Sure.
Thank you.
This one or previous one?
Yeah, just that one.
Okay. So now for this problem, it says that the intensity of a television signal, so intensity, I'm going to write I for intensity, equals,
all good, thank you.
Equals k over d squared. And I think the person that emailed me read squared instead of putting d squared, put the square root of d. There's a difference between square and square root, of course. Anyways, so this is what I'm going to be using. So now from the information that and the literature of the problem, it is telling me that if the intensity is 16 watts, so 16 equals, okay, k, that we don't know what it is, divided by distance squared, so 0.75 squared. And let me just rewrite this a little bit better. Do you see how I got this from the
Do you
literature?
not want to convert units now, or do you do that later, or does it not matter?
Oh, I mean, what unit am I converting in this problem, may I ask?
Yeah, so if the intensity is 16 watts per meter squared and the distance is in kilometers, do you not bring kilometers down to meters, or does it not matter?
Okay, did that. No, in this one, distance of 0.0 kilometers. So let's say the sampling of television as the square distance from the transverse intensity of 16 per square meter. Okay. No, I didn't change it, and I got the right answer. Yeah, so it has to be. So let's just figure it out. Let's just figure it out. So if I multiply both sides of this equation by 0.75 squared, I get k equals, and I wonder who just joined in. I don't know if that person, if you heard me or not. If you go and come back on the time of midterm, if you're dropped from internet, that's the end of your midterm. You got to make sure you are somewhere with a reliable internet, whoever you are. I can't from my screen, I don't know who is that keeps coming and going. You will be dropped from the exam if your internet drops. Make sure you have reliable internet. Okay, so k equals, if I put, so let's say 0.75 squared is 0.5625. And so if I go times 16 times 16, 9. So k equals 9. So let me go now to the next page. Or I could finish it here. Now I can say the intensity equals 9 divided by 2.25 equals according to my calculator. Oh, it's 2.25 squared. Parenthesis 2.25 squared. So, yep, 1.77 repeating. Okay, so that's the intensity. Now, now I have to let you know that, like, the ones that I put on the exam, usually, if it shows up, I don't think I have it in this exam yet because it's like part of a later sections. I'm not, well, let me just check it. Anyways, they won't have different units to, so they will be pretty straightforward. Let me go to Meet. I just got to make sure that they're not.
How do you know when to use direct or inverse variation?
Oh, the literature must tell you that something varies directly. If the word inversely is not there, it's direct. It's just like, you know, like for example, if I say that if I say the distance a car stops at speed of, let's say, 50 miles per hour, okay, is related to the thickness of brake pads. Okay, so nowhere here I'm saying the word inversely is there. So this is, you know, direct because the word is not there. But the same example, if I say the distance a car stops at speed of 50 miles per hour is inversely related to the, you know, thickness of brake pads. Now this one, the word inversely is there. And really, most of the time they tell it to, I mean, the literature tells it direct or inverse. But if you don't see you know how in the past, if you put x here, you assume that the power is 1 and the coefficient is 1, and you don't have to write it. With these problems, you know, the direct is not necessary to write down, but the inverse relation, it must be written down.
Got it. Thank you.
Of course, yeah, I'm trying to find out where is midterm. Okay. I think I found it, which is, let me say, let me click on it. And yeah, I don't see inverse relation. I will do more problem in the future with, you know, more interesting ones then. Okay. not this one, not this one, not this one, not this one. Okay. No, I don't say it. Okay, so I feel better about it. All right. So I don't want to talk about anything new. Let's see what's going on after our midterm. So midterm is going to be Wednesday, and so yeah, actually I do have, since we don't meet on Friday, I need to talk about 3.6, all right, which is fairly easy. So 3.6 is about complex numbers. Also known as imaginary numbers. I really don't, I mean, that's probably the worst choice for the for this the subject in this subject in mathematics, because we are not really imagining numbers, imaginary numbers. What about imagining? But anyways, so let's say that first of all, if this is the universe of complex numbers, then the real numbers is a really subset of that real numbers. Okay, very small subset of complex numbers is a lot. I mean, it's bigger. And what is the imaginary here? So a complex number has two parts. The complex number has two parts. Real and imaginary. And once again, I really don't like the word I don't think any teacher likes that, but it's the way it is. So let's say if I have, say, 2 plus 3i, that stands for imaginary, this is the real part, and this is the imaginary, and the entire thing is complex because it's made of two parts, complex. So as you can easily say that, like, the 2 plus 0i, 2 is a real number, but 2 plus 0i, which is 2, I mean, real numbers are complex numbers. We just don't think about it that way because their imaginary part is 0. Think of number 5, 5 plus 0i, it is both real number and complex because there is no imaginary part. So how did it come to be? Is just to give you a really quick overview of that. You know that if you have x, let's say squared minus 4 equals 0, so mathematician knew that x plus 2, x minus 2 equals 0, so x equals plus and minus 2. Or you could say x squared minus 4 equals 0, so x squared equals 4, so x equals plus and minus square root of 4, so that equals plus and minus 2. All right. So back then, or like maybe as far ago as 600 years ago, mathematicians like Descartes were thinking about, what if you have x squared plus 4 equals 0? What if you have x squared plus 4 equals 0? I mean, can I have, and then back then they would say no solution. And believe it or not, even in these days in United States, I've seen in middle schools, the teacher tells students that, oh, this one has no solution. Well, it doesn't have any real solution, but it does have a solution, anyways. So if you think of this, I need to if you think of, let me put this as real numbers are, so 0 is here, 1 is here, 2 is here, 3 is here, and -1 is here, and -2 is here, and -3 is here, and on and on. And let's just put, and this is due to Carl Gauss, that he said, what if we are thinking wrong about, what if we are not thinking correctly about this? What if we say this now, this is 1i, this is 2i, this is 3i, and this is -i, -2i, -3i, and on and on. So let's pick a point. Let's say if I pick a point right here, okay, so now this is going to be 1 plus 2i. If I pick a point right here, this is going to be -3 minus 2i. If I pick a point, let's say down here, this is 3 minus 3i. If I pick a point, let's say here, this is going to -2 plus 2i. And picturing this plane that it does have, and it's not, by the way, it's not a flat plane. The best thing I can tell you, which is really, it's beyond, we really have to, anyways, it's not part of this course anyways. So if you think of that, if you hold down a curtain from the ceiling and then you curve it and fold it up, you curve it and fold it up, that's kind of the closest thing that you can think about the complex numbers. But for this class, what you need to know that this R is the horizontal, which is all our real numbers, 1, 2, 3, 4, 1.5, 1.6, all of them. And the vertical one is going to be the complex or imaginary. All right. So what we learn in this class, we need 4 operations to learn. We need to learn 4. I need to renew these pages. So we need to learn how to add, subtract, multiply, and divide complex numbers. And that's the essence of this section. Adding and subtracting there's nothing to it, it's just like before. So let's say that if I have -2i, let's say make this 4 minus 2i, and then I want to add this to, let's say, 5 plus 6i. Okay, you just add the real together, so it gives you 9, and you combine the imaginary, so it gives you plus 4i. No, nothing, extra, nothing hard at all. Let's say if you have -4 minus 3i, and you want to add that to -3 plus 10i. Okay, adding the real part together, I get -7. Adding the imaginary part, I get plus 7i. And I'm going to stop to pause and see if you have any questions. Excuse me. All right. Subtraction is the same way. Nothing hard about subtraction. So let's say if you have 4 minus 5i, and then you subtract 10 minus 5i. Well, let's make this, I don't want to have a repeated number, so let's make this 7i. Let's make this 7i. Okay. So notice that this is -10. -10 combined with 4 is going to give me a total of -6. And the imaginary part together, you see this negative times this, that's now I have positive 7i. Combined with -5i, I get positive 2i. Any questions? All right, let's do one more. How about 3 minus 2i minus minus 6 plus I. Okay, so this, my 6 looks like a B, so let me change it. This is a 6 minus 6. Okay, so minus 6 is positive 6, combined with 3 gives me 9, minus I combined with minus 2i gives me minus 3i. For the multiplication, okay, need to memorize that square root of negative 1 equals I, that you must memorize, and that I squared equals I squared is going to be let's see, is it, yeah, negative 1. Boy, all right, so let's see, let me see if I can. So let's do. Oh, I'm going to go to the next page and actually show you something. How about let's do, just looking up the stuff from your own WAMAP. How about square root of negative 5? Okay. What is that equal to? Square root of negative 5 is the same as square root of negative 1 times square root of 5. Do you see that? So that equals root 5i. Let's do another one. Maybe you could rewrite this if you want. You could say that square root of negative 5. You can rewrite this that this is square root of 5 times square root of negative 1 if it's less confusing for you. So root 5i. Because remember, we have to have this memorized that this is square root of negative 1 is I. So let's say that if we are multiplying, let's say that if we have square root of negative 5 times square root of negative 125. Okay. So here, okay, here we are going to say that this is root 5 times I, and this is root 125 times I. So this is root 5 times I times 125 is 5 cubed, so 5 root 5 times I. So that equals to 5 root 5 times root 5 is 5 times this 5 here is 25 I squared. I squared is negative 1, so that equals negative 25. I'm going to pause to see if I lost anyone. And here is, do not do this. Do not do this. In the middle school, you are remembering that you can multiply if you have square root of something. So in algebra of real numbers, okay, if you have root 5 times root 125, then you could say this is the same as square root of 100 and like 625 and that equals to 25. But this is not real number algebra. You cannot do this. Do not do this. This algebra, complex algebra, is slightly different. So if I say root -5 times root negative 125, and then you say that equals to square root of -5 times negative 125, and that equals square root of 625, that equals 25, this is wrong, because this is not real number algebra. You cannot multiply what's under square roots, two different square roots under one. You cannot do that. That's not part of the complex numbers algebra. So this is wrong. What if you have something like, let's go to the next page. What if you have something like this, something like, let me just make up one. 2 plus 4i times 1 minus 2i. Okay, so now I'm going to FOIL this. 2 times 1 is 2. 2 times negative 2i is negative 4i. Then I get plus 4i, then minus 8i squared. So now, let's see, I get 2 times 1 is 2. 2 times 2i is negative 4i. 4 times I is 4i, and 4 times negative 2i is negative 8i. Now you can combine this, the i's is going away. So this equals 2 minus 8 times negative 1. So this equals 2 plus 8 equals 10. And it wasn't intentional. This one just happened that the middle term got canceled all the way. That's not the case all the time. It just, so I'm going to go ahead and modify this example. Okay, let me modify this example, and let's just change this to, instead of negative 2i, let's change it to something like something prime. How about negative 5i? So what does that do to this? So if I FOIL this, 2 times 1 is 2. 2 times negative 5i is minus 10i. 4i times 1 is plus 4i. And 4i times negative 5 is negative 20i to the second, which is negative 1. So this equals 2 minus 6i minus 20 times negative 1. So that equals, this becomes positive 20 and a 2, so 22 minus 6i. Any questions? All right, and one last thing that I want to tell you, and of course, this is not part of the midterm, because this is, because we don't, next class is your midterm, so of course I can't stay and lecture. So, and this part is for Friday. I'm going over it now. Then that's going to be how to divide. So let's say that I have, let's make something not really big. How about 2 plus 3i, okay, divided by 1 minus I. So step 1, rewrite as a fraction. So you say 2 plus 3i over 1 minus I. Step 2, multiply top and bottom by the conjugate of the denominator. In this case, so multiplying top and bottom by 1 plus I. And then finish it up. So this gives me, on the top, I get a 2, then plus 2I, plus 3I, plus 3I to the second. In the denominator, I get 1 plus I, then minus I, minus I squared. And the middle term always cancels. If not, then you have done something wrong, or I have done something wrong, because that's the nature of the conjugate. So the final answer is going to be, on the top, I have I squared is -1 times 3 is -3 added to 2. So I have -1 real part plus 5 imaginary part. This is I squared in the denominator is -1. I have a negative in front of it, so that's +1 over 2. And that's how you divide. And then there are videos attached to your homework, so don't sweat it. This is one of the easiest sections there is in this class, and which is a perfect thing because it's right after the midterm, so you can do a little bit of rest. Okay, does any of you have any question that you want to ask me?
Is the homework we do today going to be on the exam?
No. Oh, the homework that we do today, let me check. I thought you were talking about complex numbers, my bad. The homework that we are doing today is Monday 3.4, 3.5. Let me check it. Oh, yes. Yes, it's, yeah.
Okay, thank you.
Sure.
Would you be willing to run through number 13 from the 3.4, 3.5 homework?
3.4, 3.5, 3.4, 3.5, number 13. Oh, yeah. Thank you. Yeah, that's actually a good question. So, and I know, what to tell you to just maybe just spark your brain. If I tell you x squared equals 100, what is x equal to?
10
10.
or -10.
Plus and minus 10, yes? Okay. So can you have one answer without the other? No, you can't, because that score demands it. All right. Now, if you have a cubic function, f of x equals something, something, something. Okay. So would you agree that this is linear, this is linear, this is linear? Would you agree that if you know this one, the remainder is a quadratic?
Yes.
So if one of the roots is root 5, then minus root 5 must be there. It has no choice. So let's look at that problem that you mentioned. Thank you. That's a find an equation for the third degree polynomial with rational coefficients that has a root of x equals root 6, x equals -5, and p of 0 equals -60. So if x equals square root of 6, what other x is there that they're not telling you?
The negative square root of 6.
Yeah, so does it have a choice?
And it doesn't have a choice because it's the
Because
square root.
because you see, you have some f of x, which is cubic, right? Right? So now p of, let's say, x equals root x equals -5 takes care of one of them, which is x plus 5, yes?
Yep.
Wouldn't this be a quadratic now?
Yep.
Yeah, so you have x squared over something. So if one of them is x minus root 6, this one must be x plus root 6.
And so the reason the other one isn't x minus 5 instead of x plus the square root of 6 is because it is asking for rational coefficients.
Okay, so if x equals -5 is a root,
Mhm.
okay, then x plus 5 equals 0 is a factor. Remember the factor theorem?
Yep. Yep.
Okay. So in here, x equals root 6 is a root, so x minus root 6 is a factor.
Yep.
Therefore, x plus root 6 is the other factor.
So I guess what I wasn't entirely certain was why x plus root 6 was the other factor versus x
Okay.
minus 5.
Well, I'll tell you.
Okay.
If you have y equals x, that's linear, huh?
Yep.
If you have y equals x plus 1, that's linear, huh?
Mm-hmm.
So let's multiply this. You have y equals x squared plus x. Isn't that quadratic?
Yep.
Okay. So now let's expand this. If you have y equals x, let's say, and y equals x plus 1 and y equals x minus 2. Then if I multiply these three, wouldn't I get x times x plus 1 times x minus 2?
Mm-hmm.
Wouldn't that be a cubic?
Yep.
Yeah, because every time you factor them out, every time you factor a cubic, so if you have like y equals something times something times something, then you have three linear, or you can say I have one linear and a quadratic. Yes?
Yep.
Yep.
That makes sense. Yep.
Yeah. Okay. So let's finish that example. So we have so the information that we had was x equals root 6, x equals -5, and p of 0 equals -60. So we know that x equals negative root 6 is also there. And I really hope that you see that it has no choice, because when you solve for a quadratic, you get a plus and minus. If you have a cubic, you take a linear factor out, you're left with a quadratic, and then you get a plus and minus. So this is going to be, so p of x equals some a, we don't know what a is, x plus 5, x minus root 6, x plus root 6. And so if I multiply that through, I get, let's see, and we know that p of 0 is 60, -60. So -60 equals some a. If I p of 0, so x is 0, so that's a 5, that's a negative root 6, that's a positive root 6. So that gives me minus 60 equals negative 30a. So a equals positive 2. So p of x equals 2 times x plus 5, x minus root 6, and x plus root 6. And now I believe OneMap wants you to multiply through. So let's do it. Let's do these two together and these two together. So that gives me 2x plus 10 times x squared minus 6, because that's difference of 2 squared. And now we can just multiply them. So I get 2x cubed, then I get minus 12x plus 10x to the second minus 6. We have a few more, of course, yeah. We have a few more minutes if anybody wants to ask a question, except I cannot tell you what's
Thank you.
Of course, yeah. If you don't have a question, have a wonderful night. Please do study. I'll make myself available a few minutes early next class just to give you the password so you can start your exam a few minutes early.
Good night.
Good night. Thank you.
So we'll join Zoom before the test, and you'll give us the password on Zoom to access the test.
Yeah, I
Okay.
you know, so once you see yours, when anybody who joins, their name comes to the chat, so I can just click on it and send it to you directly.
Perfect. Thank
Yeah,
you.
of course. Yeah, have a good night.
Yeah, you too.
Thank you.
Thank you. Bye-bye. Did you have any question, Kyle? Michael? Question? Oh. All right. Good night.